Live from B201 is the statistical show, part 2 of Form A. So last question we did was number 13. Find the total variation. Do you remember how we did that? L1, L2. We found the, let's see, L3 was Y hat. L4 was Y bar, L2 was Y, L1 was X's, and your equation summation of, is it Y minus Y bar? Okay, Y minus Y bar squared. So we found this from your sum list catalog under sum is under second, list, I believe math. You can double check that. Then we typed in this is L2 and this one is L4, and then we squared it. Again, for the TI, when you type it out, you need sum with an extra set of parentheses, and then you can put in your L2 minus L4 squared. Okay? That's how we typed in and get our answer. So that was our total variation. You remember what page that was on? Page 533 or something like that? Somebody double check that. I think there's like 4 equations on that one page that we said you probably need for the test. All right, number 14. Construct the prediction interval. So, do you remember what the prediction interval is? Y minus E. Okay, and then prediction interval Y hat plus E. So it looks like they're giving you the standard error of estimate is 5.4. Or are they? 99% prediction interval for the test score, spending hours on the test, Y hat. So they're asking you to predict when X is 7, what is Y? So how do you find that value? Yeah, you put 7 in for X in the equation, so it's going to equal 44.845 plus 3.524 times 7. And what do you get when you do that? That equals Y hat. That's our prediction. So what is our predicted value? That's where actually somebody's going to have to open their calculator and punch some buttons. Anybody else get that? 69.513. Okay, obviously that's not any of the answers, but 69.1513. 69.513. It goes in for Y hat. This is Y hat, and what is E in the problem, and what is E in the problem? Now before we ran that program, but I'm thinking that you might use this number. So what do you get if you subtract 5.40 or add 5.40? If not, we got to go through the long process of finding the t-score, plugging in N and E and all that other stuff. So it's 69.513 minus 5.40. 64.113. What about 69.513 plus 5.4? 74.9. Well, that's not going to get it, so off we go to the program. I know. All right, so how do we find, for the program, we need 2 numbers. So to find E, we have to put our information into L1 and L2. 5, 2, 9, 6, 10, 64, 48, 72, 73, and 80. So you have to put that information in Y at Sage. Turn your book to page 754. I believe it's 754. We're going to have to find our t-score. Alpha is equal to 0.01. Is it page 754? Okay. So we got alpha at 0.01. We got n equal to 1, 2, 3, 4, 5. So our degrees of freedom is going to be 3. So what's our t-score going to be? 5 point what? Okay. And then x is equal to 7. Once you have all that information typed in, you remember which program to run? What's it called? Yeah, we called it E. So run program E. And tell me what the value you get is. $34.67. All right, so what is 69.513 minus 34.67 and 69.513 plus 34.67? What's the plus one? Okay. Yep. What's the minus one? So is that close to anyone's up there? Yep. Looks like A, doesn't it? 34 to 105. That program saves you a lot of time. Okay. For X.
No, I'm not in this.
No. Okay, that's our predicted value. That doesn't go in there. That goes into our program. Okay? Questions? I mean, once you have the program E, it's not too difficult. You just find the t-score and pretty much put in X. Yes?
How do you know, though, if it's like if we don't have a multiple choice, how would you know that that's right? Because, like, the first one, you just added it with,
Oh, because they gave you that for the equation E, and that's one of the variables, but we calculate the variable in our program.
oh, so you just don't.
Right, you don't have to use that.
So you always use these.
Right. Yeah. They gave you that as a way of saving you time, but since we have the program, it calculates it for us. Okay? Anything else? If you don't have the program, yeah, then you got to put it all in there and crank it out. All right. 15 we will omit. Okay? 16 we will not omit because it's asking for the, oh yeah, we will omit multiple regressions. We don't do 15 or 16. Okay. 17. The wildlife analysts gather the data in the table to develop an equation to predict the weight of bears. Check. As the independent variable in the chest length and sex is independent. For sex, he used male 1, female 2. He took his equation to the forest and found the male bear whose chest made 40.3 and who was 64 inches long. Use it to find the multiple regression equation. Well, we don't do multiple regressions because we're not going to use the TI, so we're going to omit that one also. This kind of stinks. Whew. Moving on.
Omit.
Wait a minute. We might have to come up with something here. Okay.
Omit.
Wait a minute. No, we might be able to do this
Now
one.
it's a multiple regression, right?
No, but it gives you the printout, so give me a minute. Use computer software to find the best multiple regression equation. Explain the variation of the two. Y divided by that. Y divided by that. Divided by that. Divided by that. Oh no, just a minute. We're not done.
Omit.
No, no, no. Let me see what's happening here. 1.25, 1.55.
Yeah, I don't know how to do that.
No, I'm thinking. All right. Here we go. So number 20. Oh no. This one is your scatter plot. Identify the model that best fits. Remember, these are your choices: linear, quadratic, logarithmic, exponential, and power. So, when you have this, you're required to show me your scatter plot. You're required to show me your graph. You're required to show me your equation. And you're required to show me your prediction. Oh no, in this case, there's no prediction. Okay, so you have to have all three of those. So first thing is to do what? L1, L2. So 1, 2, 3, 4, 5, 6. Step into L1 and L2. I might follow along with you on this one. Okay. Quit. Clear. Clear. All right. Stats. Edit. So I got 1, 2, 3, 4, 6. Now we got 16, 63, 146, 255, 403, 572. Oh, so everybody has it typed in? All right, what's the first thing you can do? Okay, so how should I look at the graph? Okay, if I hit graph, zoom, stat. Okay. Now, also make sure that your stat plot is turned on. You can go to y equals and turn it. If you don't see anything on there, it's off. If you go up there and turn it on, it's highlighted. That means it's on. You can see your dots. Okay. So after you do that, go to zoom stat. It'll set it up for you, and there you go.
You guys draw the graph?
Yep. Draw the graph. Put in your information. I forgot to put it in over here. 1663. No. No, I'm just writing this down to tell where the values go. All right, so now you have this. How do you find out your best regression? Remember, you have 5 of them to choose from. Do you remember how to do that? Stat. Calculate. What's the first one? Okay, I like to use a plus bx, but that's okay. So there's your first one. How do you make sure that your numbers show up, your R values? What has to be true? And also, your diagnostics have to be on. Have to be on. So there's linear. Next is quadratic. Stat, calculate, quadratic. Oops. Stat, calculate, quadratic is 5. All right, there's my output for that one. You have to make sure you write the R's down so you know which one it is. You look for R squared. So you're comparing these. Okay? So then after quadratic, they tell you it is logarithmic, stat, calculate, which one's logarithmic? ln is logarithmic. No, just these, because not every calculator has those. You have to write down what your R squareds are for each of these on your test. Yeah, just 5. You're only doing 5 of them. Yeah, you write down the R squared for each of them. No, right now you don't on your test, and Form B you will. So stats, calculate, after natural log was exponential. Stats, calculate, exponential. Again, there's another r squared. Stats, calculate. What's the last one? Power. Okay. So you have those. Now you compare which one's the best fit. Looks to me like there's 4 nines right there, but right here there's 4 nines and a 3, and here's 4 nines and a 0. So it looks like it's power regression. Okay? Now remember, we said you want to do that as the last one you calculated. In this case it was. If not, you go to stats, calculate, and you calculate the best one over again so it's in the memory of your calculator. Okay? Then we said you would go to y equals, and you would go to, do you remember where to go to your equation? Bars, stats, equation, regression equation. It puts it in there for you. Okay? Stats. Then slide over to EQ. And press, and then we press regression equation. It should pop up into Y1. Did it? Then you press graph. And it goes through there. I'll just tell you right now, on your test, there is going to be something to predict. So you're going to need the equation in your calculator. So you have that. And for instance, if this was, I would add to it, say, predict x equals 7. Okay? Yeah. That's fine. Yeah. And you do your second calculate value at 7. Okay? An invalid dimension means your window's not quite big enough, so make it a little bigger by going to 8. Okay? Yeah, make the x maximum 8. Your x maximum has to catch your prediction. Yeah. Your window's only going to 6.5, so go to your window and change x max to 8. And on your graph, second, calculate value, when x is 7. Okay? So you can see right now that one's going to be, and you have all this written down from your power regression. That's your equation. You only need 4 decimal places. Okay? Everybody get the value? You get it? Well, that means you have to go to your window. And your x minimum should be 0. Okay? And now you should go type in 57. Anybody else? All right. So, I'm going to, I didn't even check. Was our answer right for the regression? D? I didn't even see, was there an option? Oh, it got cut off? Okay. Anyway. So, I think we're in good shape. Oh, I see it. Right there. D. Okay. Oops, I gotta stop this.